Hit subscribe so that many and maximum people can get the information at once, and maybe you can also enjoy the video as well. So today we're gonna start with your chemistry class 11th, and that is your 25th class of the session. That is unit 11 is the P block element. In the same way, for the P block element we'll discuss, and that is, as I told you, that is your 25th class of the session. We had discussed your 24th class of the session in the last classes, and of course that has been a very important one. And if you had not gone through with the same, and you can go ahead here so that you will get to know about it all in the detail. So here for this 25th class of the session, we will discuss many more very important questions in terms of reality towards air. So for the same we will go ahead, and that first of all we'll start discussing about the reactivity towards air. But before that we will start discussing about the atomic and the physical property of a group 13 element, which is very important. So let's go for the same. So here we go. The table is all about atomic and physical properties of group 13 elements. Okay, so first we'll discuss about the property. In property, we'll make a table here. So yes, this is element, the second is your element. So in element we have the first element is your boron, which is the symbol we have B. Another is your aluminium, which is Al. Then another is your gallium, which is Ga. Then you have indium, In, and then of course you already have your thallium, which is Th. Okay, so we'll go for it one by one. First element we will be discussing here is the property we'll discuss is your atomic number. So the atomic number we have for boron, we have atomic number 5. For aluminium, it is atomic number 13. For gallium, atomic number 31. For indium, it is 49. And for thallium, it is your 81. Okay. Another property we'll discuss is about atomic mass. So atomic mass that we have here, which is gram mole inverse. Then another property we'll discuss, electronic configuration. Then we have atomic radius. Then atomic radius per field. Then we have ionic radius, m3 plus by pm. Then we have Ionic radius, it is Ionic radius. Okay, so further we'll discuss that is, then we'll discuss the rest of it. So coming towards atomic mass, for boron we have 10.81, for aluminium 26.98, for gallium 69.72, for indium 114.82, and of course for thallium it is 204.38. Coming towards electronic configuration, helium 2s2 2p1, for aluminium neon 3s2 3p1, for gallium argon 3d10 4s2 4p1, for indium krypton for krypton 4d10 5s2, this is 4p1, 4 5s2 and 5p1. For thallium it is Ze 4f14 4f14 5d10 and 6x2 6p1. For the atomic radii that we have, for the boron one it is your 88, and for aluminium that we have as your 143. Coming towards the gallium that we have your 135, and for indium it is 167, and for thallium it is 170. Coming towards your ionic radius that we have in terms of M3 plus by PMB, which is your 27. For aluminium it is 53.5, the gallium is your 62.0, and for indium it will be 80.0, and then for thallium it is of course 88.5. That we have for the ionic radius, which is M plus by PM, and that is for boron that we don't have it. So for the ionic radius, as I told you, it is M plus by PM, which is P. In terms of for the ionic radius it is PMB, and for the ionic other than the ionic radius in terms of M plus for by PM, that is the another one. So you have to just continue with the same. And for aluminium it is, of course, it is not yet found. In terms of gallium, for the element that we have for the ionic radius M plus 3, it is 120, and in terms of indium it is your 140, and for thallium it is 150. Okay, so coming towards the another one, which is your ionization enthalpy in terms of kilojoule in ionization enthalpy in terms of kilojoule mole inverse, which is of delta R of H1 for delta 2 H2 and for delta 3 H3. So in the same way we'll discuss about it. So here we go discussing about it for the ionization enthalpy here. So let's figure it out accordingly, and then we'll be surely we'll be finding it out. So for the same, it is ionization enthalpy. In terms of kilojoule mole inverse, so delta IH1 and delta IH2, delta IH2 and delta IH3, it is all about, that is we'll be having a, for boron it will be different for delta H1 it is 100 or 801, this is 2427, and for delta H3 it will be to 3659. Okay, Coming towards for aluminium for the same, and respectively we'll discuss the rest of the things as well. So yes, we'll go for it for the aluminium, which has been your 577 for H1, and 1816, and that is 2744. In terms of for gallium, it is 579, 1979, and for of course delta H3, it will be your 2962. Coming towards indium, we have your 588, 1820, and 2704. In terms of thallium, yes, it is your 589, 1971, and 2877. Okay, so did you get that? And we'll discuss the rest is your for electronic negativity. So of course that has been important one, and yes, we'll be going to continue, and even though we'll be discussing about the reactivity towards your inevitably exceeding, so we'll discuss that in the next coming class, but of course we'll surely be ending it out with the table. So this is very very important. You can just write it on, and it is helpful for the NCERT exam as well as for the board exams as well, and that is important for the competition paper if you are giving for the engineering papers, as well as for the and the NEET paper as well. So these were the electronic configuration that you will be have to handle it out. Coming towards the electronegativity here, in terms of electronegativity, we have for the boron, it is your 2, and for coming towards for aluminium, it is 1.5, and for gallium it is 1.6, for indium it is 1.7, and of course for thallium it is 1.8. Now coming towards the density here we go. For the density, it will be gram centimeter cube, which is at 298 Kelvin, and that is your for the same. It will be your 2.35, 2.70, 5.90, and 7.31, 11.85. Coming towards melting point, it will be your for melting point. So in terms of melting point by Kelvin, we have 2453 for boron. For aluminium it is will be 933, and for gallium it will be 303, and for indium it will be 430, and of course for the thallium it will be 576. So here we go for another one, which is your boiling point. By Kelvin. Now we'll discuss the rest properties we have here for the boiling point. Other than that, we'll be discussing E volt by V for M3 plus by M, and of course that is E by V for M plus by M. So this is very important. As I told you, for the boron category, it will be your 3973, and that is of course not yet defined. 2740, and for this for M3 plus by M, it will be minus 1.66. Okay, I think it has been visible. Yeah, so it will be plus 0.55, and for this it will be the boiling point will be 2676 minus 0.56, even though with a minus sign. Here it will be for the gallium, it is minus 0.79 acid, and of course minus 1.39 will be the alkali. Okay, so for this it will be 2353 minus 0.34 and minus 0.18 for the indium, and for the thallium it will be 1730 plus 1.26 and minus 0.34. So here we're gonna end up with, we'll discuss about the rest of the classes in the next coming class, which is of your 26th one, and that will be surely go ahead here. So here we're gonna end up with, and please go ahead with like, share and subscribe so that you will get all the related information towards it. And this is after so long I had done this, but of course it has been important, so go ahead. And thank you, hope you enjoy this video, or if you like this video, please go ahead with like, share and subscribe. Thank you.